Tom, how do physicists explain dark energy, dark matter, and what is your MBT view on this subject?
We make that up. We assume dark energy exists because we see that the universe is not only expanding, but that expansion is accelerating. And we have no way to justify that based on the physics we know. And rather than say the physics we know is probably incomplete then, or our understanding of reality probably isn't complete then. Instead of saying that, we say, oh, there must be this dark energy that makes it do that. You see? So what's going on there is that rather than looking for a more general physics that can explain that idea, that fact that we are expanding, with acceleration, instead of looking for a better, more complete physics, we take the limited physics we've got and make up stuff in order to make the equations work. All right, well, here's all this dark energy. Now that's why the universe expands. So look at that process. You have a phenomena that you see, like dark energy, and then you make something up to explain it. And then you name that stuff you make up. Oh, it's dark energy. And here are its properties. So let's look at a photoelectric effect. You have a photoelectric effect and you have something that is photoactive, okay? And then you have a photon that hits that photoactive thing. I mean, this is the explanation. The photon hits that thing and say, out goes an electron, knocks an electron out. All right. So that would be a photoelectric effect. Now, that's our explanation for it, just like dark energy is our explanation. So how does that work out? Well, what it says is that when we expose this surface that is photoactive to light, we generate a charge. We generate currents from it. Sunlight shines on it, and electrical current flows. Oh, well, we make up, why is that? Oh, well, the light has photons because we find out that we can reduce that light shining on it to just individual chunks. And we can't reduce it any more than that. So we say, there is a single, there's individual chunks here. We'll call them photons. And that photon will knock out a thing we've called an electron. Well, that electron is also something that was just made up and made up as an explanation for something we observed. Now we're going to make up a photon to be an explanation for something we observe, and so on. And we build this up and we call that science. But you have to realize that all of these things, the electron as well, is just something, a model that we create to explain something we measure, something that we experience. Okay, so we make up a model and we say, here's our model. There's electrons and they're little chunks of mass with charge, and they zip through wires, and that makes current, and that makes motors run and other things. But we realize that model really isn't true. It's just a model. Because if you try to actually do physics with little chunks of mass with charges, you can never get the right answer. It doesn't make sense. It doesn't work. You have to look at electrons as points with attributes of mass and charge. Then you can do the physics and it'll work. So you see, they're not really little chunks of mass with charge. That's just our model to help us understand it. Photons aren't really little chunks of light. That's just a model. It's a thing we make up. So how do these things that we observe actually happen? They are modeled in a virtual reality with equations. Very similar equations to the very ones that we find when we make up models that are somewhat accurate. Okay, so let's talk about our elf. And our elf is in the world of Warcraft. And in the world of Warcraft, you have things like rivers, streams, and cliffs, and trees, and rocks, and buildings, and other people. Okay, now, an elf little elf scientist here, he takes this rock and he drops it off the edge of a cliff. And he says, oh, everything goes down. And being a bright little elf, he says, gravity. There must be a thing called gravity here. And why does that happen? Well, it looks like all masses attract each other. Okay, now we got a little physicist elf who's decided that his realm has gravity and that all masses attract each other. Okay, it's sort of like what we did back when we came up with that same idea, masses attract each other. Okay, so we have that. What's really going on? What's really going on is it's a virtual reality. There are equations written that say when something has no support and it's heavier than air, it falls. And if you throw it, it goes on a parabolic trajectory because it has this constant acceleration toward the center. That's the mass attracting mass. So it's being modeled that way. The rendering engine that renders it has the equations in it that make it act that way. Okay, you're this little scientist elf, he dives into the river and finds out that he can't breathe underwater. Why is that? Well, it's because it's modeled that way. In the modeling, this little elf, we require that its head stays above water. Its head stays in the air, the supposed air, or it will drown. And sure enough, our elf, if he stays underwater too long, will drown and will die. Why does he do that? Well, because it's in the equations that describe that virtual reality. It's in the rule set that says if elves stay underwater too long, they'll drown because elves are air-breathing things. Now, is there air in World of Warcraft? Does the elf need oxygen molecules to keep his little virtual body alive? Of course not. It doesn't matter. It's just being rendered that way from equations. Now let's go to our reality. Here we are. I'm sitting here and I'm talking to Donna. And do we need oxygen? Does oxygen have to keep us going and keep us alive? Is there oxygen all over? Am I breathing air? Not necessarily. But how do I know that there's any oxygen here? Well, if I get out my little oxygen meter that tests to see whether there's oxygen, oh, I'll find some because it'll be rendered then. If I don't get out my little oxygen meter and make a measurement, why would the system render oxygen if nobody is seeing that rendering? It doesn't just render things for the joy of rendering it. It renders things because people make measurements. People are interacting. So you don't have to render a brain in your head or a heart in your chest. Oh, you listen with a stethoscope. All you have to render is lub dub, lub dub, lub dub. You render that in the ears of the person, but that's just a sound. You don't have to render anything more than what is measured. That's how virtual realities work. It'd be very inefficient to make a virtual reality where you compute every possibility and then just use those ones that get actualized by people. That would be a silly way to make a virtual reality. You only render what some character in that virtual reality would be aware of. But you have rules. And what are our rules? They're called physics, right? It's all the understandings that we have. Now, we have gravity here. And you know that masses attract each other is a pretty good model. But it doesn't do well if you're talking about relativistic things. So then we make up another model. We say, all right, it's not masses attracting each other. It's that space-time is a fabric of space-time is warped by mass. And gravity is just smaller things rolling downhill into that warped space-time hole that, you know, or valley that's being made by the heavier thing. Oh, okay. Now that works better if we're talking about relativistic things. It's just another model. Is that really true? Is there really a fabric of space-time that warps? Of course not. There's just equations that render things as if that were true. Equations that rendered things as if masses attracted each other. So when masses attracting each other was the appropriate answer that's satisfied, then that's what you get. That's what you can measure. When you can measure more subtle things like relativistic effects that you don't measure just every day, that takes some very special kinds of measurements, then you have a different result. It's all in the basic rule set that helped evolve this reality, this virtual reality. So think about how the virtual reality started. It started with initial conditions and a rule set, and then it just was let go so that the initial conditions could change according to the rule set. And they did. And now here we are. Okay, that created universe, that created the planet, that created the sun, that created the cells, the microbes, the trees, the bushes, and lizards and frogs and fish and us. All got created out of that evolution according to that rule set. Okay. So it has all the equations necessary to project what evolved out of that rule set. It's the rule set are the equations, you see? So it has the equations for everything that has happened here because it had to describe it. That is the rule set. What does science do? We dig out rules. But we're digging out rules that enable this virtual reality to be rendered, not rules that describe physical things that are happening. That's the difference between being a materialist or seeing that this is a virtual reality. One, you say where the rules are how material things interact with each other. The other is saying the rules express how this virtual reality is rendered. Now, you take those two ideas, and since you live here, you'd feel like, well, the one that's materialist actually sounds better because, material things interacting with each other. I get that. That's more reasonable. But when you take that reasonable viewpoint, there's a lot of things you can't explain. You can't explain. Where does time come from? Where does charge come from? Where does mass come from? You can't explain any of those. Why shouldn't a double slit experiment particles distribute themselves in an interference pattern when they're only coming one particle at a time? No answer for any of those things. So you realize that materialist view is just wrong. You can't model reality as a little, an electron, as a little chunk of mass with a charge. It does not work. If the particle physicists tried to do that, they would not be able to get the right answer or what happens when they smash particles together in big atom smashing machines. They'd always be wrong. They could never figure out what happens, but they model it as a point with attributes. Now they can get something. There is no particle, you see? So even though that materialist viewpoint seems more obvious, more obviously true, it runs into problems, things it just cannot bring answers to. It can't say, where do the initial conditions and the rule set come from that started this? It can't deal with that either. Can't deal with that beginning. It can't deal with purpose. What's the purpose here? What's the point? It can't deal with a lot of things. So there's a lot of big questions, both in philosophy and in physics, that just are unanswered because the materialist viewpoint does not have the right answer. So it's not the better physics. It's not the bigger physics. It's a subset. Within this little picture, gravity works like this. Oh, within this bigger picture, it works a little differently. Like the difference between Newtonian mechanics and quantum mechanics. Quantum mechanics is accurate within the subset to which it applies. You see, quantum physics applies to a larger subset, but still doesn't have all the answers. So what you look for is a bigger and bigger physics, a bigger and bigger viewpoint of physics. So physics sees the biggest viewpoint, and then it can explain everything. As long as it's only looking at a subset, we're only looking at things that are slower than this and heavier than that. All right, now Newtonian physics works really good, but it's limited. And so is quantum physics, limited. Can't explain a double slit experiment. You see, so is, relativity, limited. Can't explain why C is a constant. So that's the point. You're looking for a more general physics. And this idea of virtual reality, this being a virtual reality, supplies that. So what would physics look like if it wasn't material based? It would look very much the way it looks right now, because we'd say, from the viewpoint of the avatar, things work like this, because that would be inside the virtual reality. But it would also realize that there's a bigger viewpoint, and it would explain why individual particles rearrange themselves into interference patterns. It would explain that, and it would explain where time comes from and where charge comes from. It would explain those things. So now you have a more general physics, but you still have subsets of it. The subset called classical mechanics, Newtonian physics, that still works as applied to things inside the virtual reality. So it doesn't go away. It's not like the old physics disappears. You just realize that the old physics works within a certain subset of reality. It doesn't work as your reality. If your understanding and awareness of reality gets bigger and bigger, your materialist only works with this subset inside the virtual reality, and it only works in this subset just with things that aren't too fast and aren't too small. You see, so physics has evolved like that from the very beginning. It starts with the little picture and keeps working its way out to bigger and bigger pictures. That's what happened with Rutherford when he said, "Oh, look, we have atoms and they have a nucleus at the center, and other stuff is scattered far away." Well, now it was the first concept of an atom, and concepts of molecules. All these things was the physics getting more and more general. Well, now the last step in that process is to realize that this is a virtual reality and let the physics get more general so that it can explain everything. All the old physics still explains the subsets, just like it always did. So there's not a big change in physics. And right now we do exactly that with all of our physics, with all of our standard physics, is that we make up things. We make up little models. We're going to model this event with an electron and a photon. And here's our model. Okay. And when we can model something, the problem is we then start to believe in that model, believe that that model is the truth. It's not the truth. It's just a model. And that model typically turns out to not be good all the time everywhere. It's only good in certain regions. You see, so you have to realize that this physics that you think is fundamental and true and laws and will never change and applies to everything isn't. It's just a subset that applies to just certain things. There's other physics that applies to other things. And if you see it all in the big picture, you see it's all one consistent thing. So that's kind of the point.
This subset you're speaking of, quantum mechanics and relativity are at odds with each other within this subset. And you've solved that with the bigger picture of this virtual reality concept. As Einstein said, you cannot solve a problem within the subset of where the problem lies. So you have taken the bigger picture view of this must be a virtual reality, and thus you've bridged quantum mechanics and relativity, which really was what Einstein was looking for.
Sure, absolutely. So my model is the next kind of more general physics, and it does explain why C is a constant and why particles act like probability distributions. It explains those, and they're both logical explanations. And you can see how both things work and the realms in which they work. So it's just physics will do that. Now, maybe it'll one day expand past the point of virtual reality. Maybe that's only one more step, on a path of seeing a bigger understanding of things. That's how it works. Now, if it is, I can't conceive of it. I don't know how it could be expanded any further, but then materialists didn't know how their material reality could be explained any further either. So it doesn't mean that there isn't, that the process can't keep going, but it isn't something that has an infinite number of layers. You do get eventually to a point that is the answer. And at this point, I'd say that the virtual reality concept is the answer, but maybe not. Who knows? See, science has to keep an open mind. You can't be closed-minded about things, but the virtual reality viewpoint explains all the things that the materialist viewpoint can explain, plus it explains the things that the materialist viewpoint can't explain. So that just makes it a more general physics. It doesn't mean that the old physics doesn't apply. So you say, well, if you let go of materialism, where are the photons? Where are the electrons? Where all the stuff will all have to disappear? No, all of that's just being calculated. It's the results that are being calculated. The things themselves are just how we model it from a materialist viewpoint. And then you should notice that throughout physics, the models keep changing. They keep growing and expanding and changing. The models don't stay the same. Just like the electron is a chunk of mass with a charge. That's no longer the model of an electron in physics. Used to be, but not anymore. We don't see it that way anymore. So the models keep changing as we get more understanding. And as these models change, they can only be explained with virtual reality. As the models get more and more general, it just leads you to the next step, which is a virtual reality. It's a probability-based reality, not a grounds-up simulation, but a top-down probability and statistics model based on the probability distributions that can be generated by the rule set.
It's interesting what you said about, I can't imagine what theory might be past the virtual reality theory that you have now, because was it in a conversation with Einstein and Bohm that they felt that consciousness was at the root of reality? They just didn't understand how.
Yeah, exactly. Yeah.
Yeah.
A lot of physicists have come to that conclusion, and like Bohm and Einstein and Bohr and Planck and Heisenberg, you name off kind of the creme de la creme of physicists over the last 100 years or 200 years. And many of those, if not most of them, have come to the conclusion that consciousness, quote, somehow, end quote, is at the core of all of this. But they had no idea how that could be. But their science tells them that consciousness is a key player in this physics. But they don't understand how that works, how you could apply it. How could it be a thing? What are the equations for consciousness? You see, they don't have them. You can't describe consciousness from a material basis. It's not a material thing. So that's why it's hard. That's why you have the hard problem. The hard problem is hard because it doesn't have an answer. The brain does not make consciousness. And that's a really hard problem because it doesn't work that way. So yes, that's the idea, is that people have had now for 100 years the knowing that consciousness is at the root, but they did not have the concept of virtual reality. And only the last probably 40 years, 30 years has virtual reality been a concept that people could wrap their minds around, could actually see the potential. Now, when we see virtual realities that are very realistic, we can experience them that are very realistic. It's not so hard to imagine that you could be living in one as an avatar. Whereas 50 years ago, that was a crazy idea, completely insane. Today, with the computing we have, it's not insane, isn't it? It's a little far out on the edge, sure, but it's not insane. We could see that. Yeah, that's a possibility. So Anyway, science is getting closer and closer to the point where they can see virtual reality as the correct answer. And as they get there, then physics will be more general, and they'll understand a lot of things that they don't understand now. So physics isn't going away. Don't worry, you know, your current will still flow in that wire just like it always did.
Yeah.
But whether that effect of the current flowing in the wire is calculated or whether it's generated out of physicality, you see, that's the difference. The current's still going to flow in that wire for that avatar, you see, but it's where does that come from? What's the real source of that? And if you say, well, it's physical, you run into roadblocks that you can't answer. If you say it's virtual, the roadblocks are removed. It's just that simple. It's a better physics.
Well, thank you, Tom.